Hello, grade twos. I hope you had a great long weekend and that you feel ready for the week ahead. Hopefully we can go back to school very soon. Okay, today we're going to carry on learning about materials. So we've already learned about different types of materials, the properties of materials, why materials are useful. Is it a silly or sensible material to make an object out of? Okay, so there are different reasons why we choose materials to make certain things. And then today we are going to test some materials. So we're going to do an investigation. Okay, so we're just going to learn how to plan and carry out some fair tests. Alrighty. So what do you need today? You're going to need your pencil, okay, with you at your desk. Okay, you need your activity book on page 30. You're going to do it for homework. And then now, during the video, you need your worksheet 5.4 testing materials. It looks like this. You don't have the worksheet, you just get a piece of paper and you copy the worksheet onto the paper and you fill in the answers, because we will need to check the answers together. So please, if you cannot print, okay, please do it on a piece of paper. Okay, so let's quickly do some revision. Remember, we learned, is it a silly or sensible materials? Okay, so is it a silly or sensible material? Or are these silly or sensible materials to make a pan? Okay, so glass. Is glass a silly or sensible material? Remember, silly means that it's not a good idea. Sensible means it's a good idea to use that material. So glass, it would be a silly material because glass can break easily, and if it gets too hot, it can crack. Okay, metal would be a sensible material. This pan is made of metal. Wood would be a very silly material because if it gets too hot, it could catch a light and cause a fire. And paper would be very silly because it would just burn. It would not cook your food. Why? Why do we say all of these things? Okay, because we need to think about the properties of a pan. So we need something that will not burn. Okay, that is why metal is a good option. Okay, let's do one more. So the window, okay, which material would be a silly or sensible material to make a window? So you need to think. A window needs to be transparent, okay? It needs to be quite strong because if it rains a lot, okay, it should not break, okay? And it needs to protect us from the outside winds and birds and all those things. Okay, so wood would not be a sensible material. That is silly. Metal is also silly. Glass is a sensible material, and paper would be a silly material. Why? Because wood, metal, and paper are not transparent. Okay, they are opaque. So it would be a silly idea to make a window out of those materials. Okay, so we are going to do an investigation. Okay, we are going to, oh, hold on. There we go. Oopsie, sorry. Okay, we are going to do an investigation. Okay, we want to know which material is best for an umbrella. So which material is best for an umbrella? Now we think, what does an umbrella need to do? What does an umbrella do for us? Okay, it needs to be strong. It needs to be waterproof. Okay, so if we move it like this, it will not break. Okay, it needs to be waterproof so that we don't get wet. Okay, it needs to be light so that we can carry it. If it is too heavy, it will not work. And it needs to be a little bit flexible so that it can go up and down. Okay, so it can come down and be small and then open up. So this is what we need, a material that has all of these properties. Okay, so now you're going to get your worksheet and we're going to do this together. Okay, so the different materials we have are tissue, nylon, aluminium foil, and paper. So it says, which material is best for an umbrella? An umbrella needs to be waterproof. Predict, remember, predict means to guess what's going to happen in the future. Which material will be the most waterproof? The waterproof materials will not let water through. Okay, so these ones will not let water through, so we will not get wet. Okay, we have paper, aluminium foil, nylon, okay, and tissue. Nylon is a type of fabric, and then we're going to use a tissue. So here are all the materials that I used. Here's the nylon, the paper, the tissue, and the aluminium foil. Okay, so number one, we're going to test the different materials. We need a funnel and a measuring cylinder. Okay, we're going to put the material into the funnel. Okay, we're going to pour water into it, and we're going to time, okay, so that it's a fair test. We're going to time how long it takes the water to drip through. And then we're going to check how much water came through, or how much water was going into the cylinder. Okay, so first, before we begin, I want you to do your prediction. The material I think will be most waterproof is, okay, you choose. Which one do you think will work the best? It will be the most waterproof. Remember, there is no right or wrong answer. A prediction, there's no right or wrong answer. You can guess any one of those. All right. So here are all the different materials. So it says, how will you make the investigation fair? Remember, to be a fair test, we need to keep things the same. Okay, so what will you keep the same to make this test fair? Okay, so we need to keep a few things the same, otherwise it will be unfair. Okay, we need to have the same amount of water. Okay, we cannot use different amounts for different materials because then it will be unfair. Okay, the same size. Each material must be the same size. Okay, and we must wait for the same amount of time. Okay, so when we click start on our stopwatch, it must be the same time. So same water, same size of materials, and same amount of time. You can fill that into your worksheet. Okay, now we're going to look. Okay, so this is what you're going to watch the video, and then afterwards we will check the results. So let's carry on. So this is me. I'm just going to show you the video just for one material. Okay, let me share my audio. There we go. Okay, hello everybody. So today I'm going to show you how we're doing the science experiment. We have 4 different materials, all cut to the same size. Okay, you can see it in the picture. Okay, then we have 100 milliliters of water. Okay, so the same size of materials, the same amount of water. We have a funnel. Okay, we don't have a funnel at my house, so I just got a cup and I cut a hole in at the bottom for the water to come out. So first we're going to take the materials. Okay, so now the first one I'm going to do nylon. Okay, if you look closely, okay, there you cannot see any small holes in the nylon like you can see when you have cotton or wool, okay, or other materials, even like tissue. So we put the material into the funnel, okay, like that. We can hold it. I'm just going to pour the water into here so it's easier to pour, and then we can measure. Okay, so, oopsie. Okay, there we go. So I'm going to hold the nylon material around the funnel. We put the funnel over the beaker, and we're going to pour 100 milliliters of water. Okay, so the same amount of water, and I did this for each different material. Okay, now I want you to watch. Can you see if any water is coming out the bottom? Okay, oh, we start the timer, sorry, 1 minute for the timer. Okay, I'm going to fast forward the minute. See that no water is dripping. Okay, so you can see that no water is dripping out of the bottom of the funnel. Okay, so we wait for another minute. Okay, stop. So I'm going to put this back here. There we go. And stop that. Can you see no water dripped out of the funnel? No water came out. So does that mean that the nylon is waterproof or absorbent? Okay, I did the same thing with the aluminium foil, the tissue, and the piece of paper. Okay, goodbye. Okay, so now let us see the results. So you're going to write each material in the space here, and then you're going to tell me how much water was left in the cylinder or the beaker. Okay, so you're going to look at the pictures, and then you write in the amount of water that dripped through the beaker. Okay, so the first one, we did the aluminium foil. So can you see, I put the aluminium foil into the funnel or the cup. Okay, we poured the water inside, and then we watched, okay, how much water dripped or came out in 1 minute. Okay, the answer, okay, so you can write aluminium foil, and it was 5 milliliters. So there, do you see, only a little bit of water came out. Okay, you can see after 1 minute, there was still a lot of water left in the foil. Okay, and I think this 5 milliliters might have even been because there were maybe a little bit of a hole in the aluminium foil. Okay, so it was quite waterproof. Okay, the next one we did was the paper. So we put the paper inside the cup. This is how much water came out after 1 minute. Okay, so after 1 minute, 88 milliliters came out. Okay, so a lot of water came out. Afterwards, you can even see that when I took the paper out of the cup, okay, it was very easy to break. It was not strong. Can you see? It is torn. Okay, the next one was the nylon fabric. Okay, we watched the video, and 0 milliliters. So there was no water. Okay, the water was still in the cup, in the nylon. Okay, and the last one was the tissue. Okay, the tissue, 98 milliliters came out of the tissue. So almost all of the water that we poured in came straight out, and the tissue broke. As soon as I poured the water in, the tissue broke. So the tissue was not very waterproof. Okay, so you can pause the video and fill these results into your graph. Okay, and then the last thing you do is you finish your conclusion. So the best material to make an umbrella is, look at your results, and then choose which one is the best one to make an umbrella out of, which material. Okay, so for your homework today, you need to finish your activity book, page 30. If you don't have your activity book, you can print the worksheet we send home. Okay, it says, Hong investigated which paper towel was the most absorbent. Okay, so this is the opposite of what we've done with the umbrella. We want to see which one will soak up the most water. Draw a bar chart of her results. Okay, so she used paper towel. The blue paper towel absorbed 12 milliliters of water. So 12 milliliters of water it took up. The white paper towel was 36 milliliters, and the green was 22 milliliters. Now she wants to know, okay, you need to draw a bar chart, and then she wants to know which paper towel was the most absorbent. Okay, so you need to finish your worksheet and your activity book, and make sure next time when I see you in our Zoom lesson that you have your worksheet and your activity book next to you on your table so that we can mark it together. So make sure that it is ready before the lesson, okay? And that is the end. Okay, thank you, grade 2s. Enjoy your day. Goodbye.